Alright, so today's objectives for our lesson is we actually only have one. Students will use polynomial division. We're going to learn the Polydoku method to find factors of polynomials. We're going to learn two methods for polynomial division, so this is just option number one for today. So when we're graphing polynomials, it's helpful for us to have them in factored form so that we can easily plot our roots and then graph it from there. And so when we were doing this at the beginning of chapter 9, we were given equations that look something like this one, where we got all sets of parentheses with our roots as shown here, and then we were able to plot them. So I could plot -2, knowing that it goes straight through -2, and plot at 7, knowing that it bounces off at 7. Now, this is really easy for us now because we've got the roots, right, when it's given to us like this. But what happens, like what are we supposed to do if it's in the form f of x equals x cubed plus 2x squared minus 7x minus 2? What would we do with something like that that's not in factored form? Well, we're going to have to figure out how to factor that equation. And that's a little bit tricky because it's got a degree that's higher than 2. We've never done a lot of factoring with those types of things. So in order to get there, let's review how to multiply with a generic rectangle. Now, this is something that you use in algebra and should come back to you pretty quickly, but you just take the numbers that are on the sides of your squares and multiply them together to get the area of each of the little squares that's inside our box. So if you look here, if I multiply 2x times 4x cubed, I get 8x to the 4th power. And then if I multiply -3 and 4x cubed, I get -12x cubed. And I do it again on the top and fill it in. And then I'll do it again with the next two boxes. I get -4x squared here, -18x squared. Remember, you got to multiply those numbers, those coefficients, and then multiply your x's, multiply your variables. Keep filling in our box, and this is what it looks like when it's all filled out. Now you'll notice that I color-coded this so that the terms that are the same color are like terms. Okay, so I'm going to add up my like terms and write my final product down at the bottom. So I've got 8x to the 4th power, my 12x cubed and my -12x cubed make 0, and then combine my x squareds, my x's, and then my 15. Okay, so I could say that if I multiply 2x minus 3 times 4x cubed plus 6x squared minus 2x minus 5, I get 8x to the 4th power minus 22x squared minus 4x plus 15. Now that came from what I got here at the bottom when I combined all my like terms from the inside. I could also write this. Think about this like I'm dividing 2x minus 3 from both sides of this equation. I could think about it this way. If I start at the bottom and divide by this side, this 2x minus 3, I would get what's on the top. I would get this 4x cubed plus 6x squared minus 2x minus 5. Now keep that in mind because we're going to use something that looks a lot like a generic rectangle when we start dividing polynomials. Okay, so let's do some Polydoku. Now, I am a nerd, I realize, but I am obsessed with Sudoku, something that was all over books and newspapers and stuff all the time. So this is going to be sort of like that. It's a little puzzle that you have to kind of figure out. So here, I'm going to start us off with a puzzle where they give us x minus 4 on the side, -2x on the top there, and then they fill in a couple of the boxes along with part of our final product down on the bottom. So anything that's written underneath here is going to be part of that final product. Okay, so the first thing I need to do is start filling in what I can. So I know that x times something has to give me 2x to the 4th power. So I should be able to figure out that I would have to multiply by 2x to the 3rd power. Now that I know that term, I can fill in this square right here by multiplying -4 times 2x to the 3rd power, and I would get 8x to the 3rd power. Now I need to figure out what goes on the top of this little part right here. So if I know that something times -4 has to give me 12x squared. So in order to figure out what that is, I could divide. I could do 12x squared divided by -4, and I know that on the top I would have to multiply by -3x squared. Now that I know what that is, I've got to multiply -3x squared times x to figure out this box. And I would get -3x cubed. Okay, now I just multiply x times negative 2x to figure out this box. I get negative 2x squared. Negative 2x times negative 4 to get this box. And I get 8x positive. Now this next box is the trickiest part. I know that my final answer has to have a 12x in it, and I'm 2 8x. Okay, but in order for these two to add up, these two like terms to add up, this one on top has got to be 4x, so that I get to that 12 that I need to. Okay, from there, it's easy. I just fill in the 4 on the top, and then I multiply 4 times negative 4 is negative 16. Now I combine all my like terms and write my final product. So I get 2x to the 4th power minus 11x cubed plus 10x squared plus 12x minus 16. Now there's a couple things that I want you to notice about this puzzle that'll come in really handy when we start dividing. The first thing is that 2x to the 4th power in that first box up here is always going to match our very first term. Okay, there are not going to be any like terms with this box, so it'll always be the same as that. That's going to be really key when we start dividing. It'll give you a starting point. The other thing I want you to notice was how we got that 4x. Okay, so you have to use our final product, or we'll call it our dividend, in order to figure out some of the boxes on the inside. So make sure you're keeping an eye on what's down here at the bottom. Okay, let's try one that actually looks like a dividing problem now. So I want to divide 6x cubed plus 7x squared minus 16x plus 10 by 2x plus 5. I'm going to put this dividend, and I forgot my division sign right here. There should be a division sign right in between these two. I'll add it in later, but I just forgot it here. Now I'm going to always write my dividend, or the numerator if I was going to write this as a fraction, or the first thing that I'm dividing down on the bottom here. It's always going to go down there because I know that's where I have to end. Okay, I'm going to put my divisor, or the thing that I'm dividing by, on the side of my generic rectangle. And then a little trick is that the number of columns that you're going to need is the same as the degree here. So since my highest degree, or my degree of this polynomial is 3, I'm going to need 3 columns, and that's a good trick for remembering how to set these up. Now, remember I said that 6x cubed always is going to go, that first term is always going to go in this first box? That's key. That's what you have to put in first. The next thing I'm going to do is figure out that 2x times 3x squared gives me 6x cubed, so I add that 3x squared on the top. Now I'll multiply by 5 to get 15x squared. Okay, now to figure out this box, I look down at the bottom, and I see that I've got to get to 7x squared. Okay, so in order to get to 7x squared, starting at 15x squared, I know this box is going to have to be a negative 8x squared in order to get me there. Okay, once I've got that figured out, I can figure out the top is negative 4x. I can figure out underneath that negative 8x squared is a negative 20x. And now I've got to get from negative 20x to negative 16x, which means I'm going to have to add 4x's to that negative 20. Okay, last thing I got to do is put a 2 up on the top, because 2 times 2x is 4x, and then I get 10 at the end. Now notice how that 10 lines up perfectly with the number that I want at the end. That's going to be something that we're going to talk about in just a second, but when I write this problem, if I divide my original problem, I should get 3x squared minus 4x plus 2. Now you can notice that if I took 2x plus 5 and multiply it by that, I should get this on the bottom. And you could rewrite our problem to look like that if you wanted to. Alright, so we talked about how those 10s matched up perfectly, but what if that doesn't happen? What if there's a remainder? So let's look at this problem in order to see what would happen if I got a remainder. So I'm going to set this up with my 6x cubed plus 11x squared minus 12x minus 1 on the bottom, and my 3x plus 1 on the side. My 6x cubed goes right there in that box, and I know that I get 2x squared on the top in order to multiply to 6x cubed. I can then fill in my 2x squared on the bottom, and I know that I'm going to have to add 9x squared to get to this 11x squared down on the bottom. Okay, so then in order to get to 9x squared, I'm going to have to multiply 3x by 3x, and then I can fill in this 3x on the bottom. Now, to get from 3x to negative 12x, I'm going to have to subtract 15x, so that's what goes there. I fill in the rest of my chart, so I get a negative 5 on the top, a negative 5 in that last box, but our negative 5 doesn't match our negative 1, so we know we're going to need a remainder. Okay? This is something you should be pretty familiar with from when you did long division back in like elementary school probably, or junior high, middle school. But a remainder. So I need to get this number. There's some stuff left over. I need to get this number from -5 to -1, which means that my remainder is a +4. To get from -5 to -1, I've got to have an extra 4 lined up. Okay, so that when I combined those two, it would equal -1. So I'm going to add a remainder of 4. Now when I write my final answer, I've got 2x squared plus 3x minus 5 with a remainder of 4. And that's going to look like this. When I write that remainder, just like if I was dividing by 7 and I had a remainder of 4, my remainder would be n4/7. Here, since I'm dividing by 3x plus 1, I'm going to write my remainder as a fraction. That's 4 over 3x plus 1. Okay? That's always how you write your remainder, that number over whatever you were dividing by. So I realize that this is just going to take some practice. It's kind of fun to do these little puzzles. But what I want you to do on the back of your notes is to try this problem. X to the 4th minus 6x cubed plus 18x minus 1 divided by x minus 2. Now I'm going to give you a couple of hints. Remember, the number of columns is the same as the degree of the polynomial. And when you're writing this divisor underneath your generic rectangle, include the 0x squared, because there are no x squared terms, but if you include that, that'll help you figure out what needs to go inside those squares inside the rectangle. So use those 2 hints, try this on the back of your notes, and we will go over it in class on Friday.